Okay, so to highlight it in your notes, 9-30, because remember I'm going to check those every once in a while and give you points for it as a quiz score on your group, okay? So we're asked to solve. This one was on the test, and 80% of you missed it, okay? So we're going to go through it. Looking at this, we have 3 times x minus 4 is equal to 4 minus x. What? Sorry? True. Only the 29th. So write that correctly. So we have 3 over x minus 4 over 5 is equal to 4 minus x over 2. Now, guys, look at this. First of all, as it is right now, is it quadratic? No. Do you see any degree 2's in there? You guys, solving for linear problems is really easy. All you have to do is isolate x and get it all by itself. This one was trickier, though, because we were dealing with fractions. Now, notice a couple things for me. Notice a couple things. On the left, there's just a fraction. Nothing's added to the fraction out here, right? Nothing subtracted to the fraction out here. Does everybody see how on the left it's just a fraction? On the right, we have simply just a fraction. Now, if you have simply a fraction on the left and simply a fraction on the right, you can do something called cross multiply to get rid of the fractions. So the reason we cross multiply is to eliminate fractions. So I'm going to multiply both sides by 2. So I'm going to get rid of this fraction. I'm going to multiply both sides by 2. Now, guys, if you multiply this side by 2, do you need to distribute it through? No, it's going to divide out. Right? Okay. Now I'm going to multiply both sides by 5. I'm not going to write it over here because what's going to happen? It's going to divide out. Are we with me? So multiply both sides by 5. I'm not going to write it over here because it's going to divide out. Does that make sense or not? If not, then raise your hand and say it doesn't make sense, and then I can show it more in depth.
Is Garrett in your classroom?
He is usually, but he's just not here right now.
If he gets here, we said no, talk to him.
Yep. Okay, so with this, look over here on the left. 2 times 3 is? So we have 6 times x minus 4. Which is equal to, now I have 5 times all that stuff. Very important. I have to put all that stuff in parentheses. Now I've got to distribute that through. So 5 times 4. So we have 20. 5 times negative x. Negative 5 x's. Okay. All right, now let's look over here on the left again. We have 6 times all that stuff. We need to distribute it through. 6 times x, 6x. 6 times negative 4. Negative 24. Questions? I'm going to go slow. Please ask if you do. Are we all good? So we have 6x minus 24 is equal to 20 minus 5x. Now, look over here on the left, look over here on the right. Is it quadratic? No. So we're not going to use the quadratic formula on something like this. All right? We're just going to solve for x piece by piece. Now, can I just float 6x and negative 5x together? No. I've got to use the correct operation to get from one side of the equation to the other. So I'm going to add, since it was subtract 5x, I'm going to add 5x to both sides of the equation. Now, over here on the left, we're combining like terms. 6x plus 5x is how many x's? We're adding them. 6x plus 5x is 11 x's. I just added those up. So we have 11x minus 24 is equal to, notice, those added up to be 0. That's what I wanted. Is equal to 20. Now, solving for x. First of all, I saw people get to here, and it was a shame. Then they did the quadratic formula. It's a quadratic. No, do not use the quadratic formula. Way harder. You can't solve these in the quadratic formula, but this one's easy. Get x alone. So what am I going to do? Add 24 to both sides, since it was subtract 24. So I'm going to come up here. So on the left, those add up to be 0. We have 11x is equal to, now you'll add these up. 20 plus 24. 44. And my last step to get x alone. Divide both sides of the equation by 11. So we get x is equal to 4. Any questions on that? So if you see something and you have just a fraction on the left, just a fraction on the right, cross multiply it, and then you're not dealing with fractions anymore. Does that make sense? Okay, that was a good problem. She'll be seeing that again the rest of the year. Okay, no questions on that. Let's get to the new stuff then. Okay, so actually, oh yeah, this is the one, oh wow. Okay, oh wow. Please look with me at this one. You don't have to write this one down, but I'd watch. If we were solving for x on this one, is it linear? All we have to do is get x by itself. Am I true? Watch, everybody. So what am I going to do to get x1 first? -3 from both sides. Okay, so over here, that adds up to be 0. We have 2x is equal to 0. Okay, watch. Watch. What do we do next? Divide both sides by 2. X is equal to, what's 0 divided by 2? 0. About 50% of you put 2 on a test. 0 divided by 2, guys, is 0. Does that make sense? Do it on your calculator. 0 divided by 2, what do you get? 0. Does that make sense, everybody? Don't make little errors like this. It's sad when I see you get that far and then miss the problem because you did something like that. All right, any questions on that? Okay, awesome. All right, let's get to the new stuff. So today we're going to be dealing with complex numbers. Complex numbers are not new to us. We have seen complex numbers in secondary math 2. We've seen even complex numbers remotely in secondary 1. And then we've seen them in here so far. You probably just didn't know it was a complex number. We'll talk about that in a minute. So a complex number, guys, has this form, a plus bi. Once again, a complex number has the form a plus bi, where the a part is the real part, meaning the real number part. So a is going to be a real number. Now bi is the imaginary part. That's going to be an imaginary number. It's going to be a number I, imaginary number. Complex numbers are just made up of real parts and imaginary parts. So you'll be adding them together. Real parts plus imaginary parts. Now you can't combine real and imaginary parts, so it's going to have this form and stay together. You can't combine a real number to an imaginary number. So it's going to stay like this, and you're going to leave it like that. Does everybody know what a complex number is now? Now we've actually seen complex numbers in this class so far. You didn't probably know it was a complex number. So look, I just don't want you to necessarily, oh, well, we'll get there. Okay, well, that was next. So before we get to that, every number, if we wanted to get technical, and I have a student every year get technical, so I want to go over it. Every number is considered a complex number. Because 2, yeah, that's just a number, but that's the same thing as 2 plus 0i. So 2 is, you're right, 2 plus 0i, 0 times anything 0, so that would leave us with just 2. So if we wanted to get technical, every number is a complex number. And then 3i is still a complex number because that's the same, that's still in the form a plus bi because our a is just 0. 0 plus 3i. Now we're not going to really get too technical as long as you understand that technically every number is a complex number and that you can rewrite 3i as 0 plus 3i. You can write 2 as 2 plus 0i. Does that make sense, everybody? Okay, so every number is technically a complex number. Now, like I was getting into before we came to this slide, I forgot I threw this in there just for safekeeping because I always have a student say, well, isn't every number a complex number? And you're right, that's true. Okay. Don't write this down. Just look with me at this one. So we've seen complex numbers before, and I noticed on one end of level test, they had asked, write this in the form of a complex number, and the students didn't know. So I just want to briefly go over it. So we have seen things we've solved for x using the quadratic formula, and we've got down to something like this before. -2 plus or minus 3i over 5. It was a process to get there, but you've all seen answers like this, right? You remember seeing answers similar to this, right? Now, technically, that's a complex number, because we could rewrite it. First of all, we could split it up and say that's -2 plus 3i over 5, and -2 minus 3i over 5. Is everybody following me? Now, we could split that up, and you might even see it on an ACT that's written this way. So keep this in mind. Really, if you look at it, though, it should make sense. You could split this up as long as you remember that it's the whole top part, each of those things divided by 5. You're okay to split it up, but only if you remember that each part is divided by 5. So you could rewrite it like this. -2 this plus 3i over 5. Does everybody see how I split it up? This is equal to this, 2 different ways. Now look, this is in the form of a complex number. A, there's our real part, plus bi, our imaginary part. Does everybody see it? Same thing with subtraction. We could split it up and say -2 over 5 minus 3i over 5, and it's in the form of a complex number, a plus bi. So if you had this, would you know how to split it up and rewrite it as a complex number? Now that I just showed you.
Sorry, I am getting too quiet.
But he's not in right now.
He's not doing it. Okay, can you quiet here?
Okay. Okay. Yeah. But I didn't want to impact. Okay. Okay. Yeah. Okay. Yeah. Yep. You're welcome.
If I need the rest, I'll speak or together.
What is it?
I don't know if I need it. It's a trick.
All right. Any questions? Sorry, that was distracting. All right. Here we go. All right. So now we're gonna just take these complex numbers. We're gonna add them and subtract them. Now, with adding and subtracting complex numbers, you can combine the real parts and you can combine the imaginary parts. You cannot combine real parts with imaginary parts, though. So once again, with adding or subtracting complex numbers, you've got to combine the real parts. So the real parts are the number parts, and then you can combine the imaginary parts. But you can't combine real with imaginary. Now, you've done this before, guys. You really have. So we're going to go through this. Now, with subtraction, though, is where you have to be careful. When we get to subtraction, I'll make a note of that. But let's just do our first example. Okay, so we're going to simplify the complex number. Now, notice, we have the complex numbers written in parentheses, but we are adding them. Does everybody see the plus sign in here? So we're going to add our complex numbers here. So what you're going to do, guys, is because it's plus, we don't have to worry about distributing our negative through, so we can just rewrite this. 2 plus 3i plus 5 plus 2i. The parentheses are just there to say those were connected, but now when we're adding complex numbers, we can add the real parts, add the imaginary parts. Okay, so now adding up the real parts, we'll do 2 plus 5, which is 7. And then we'll do 3i plus 2i, which is 5i's. Plus 5i's. 7 plus 5i. Is that in the form of a plus bi? Yes, so we're done. Yeah. Do you have questions on this one? Wake up. I'll turn on the light. All right, let's do another one. 2 minus 3i plus -4 minus 2i. Well, first of all, you've got to pay very close attention. Is this addition? Yes, so we don't have to worry about distributing a negative sign through. We're not going to multiply these things, we're adding them. So we're just combining like terms in a sense, combining our real parts, combining our imaginary parts. So I'm just writing it without the parentheses. So then we have plus -4, so -4 and then -2i. I just threw off those parentheses. Questions on that part? I just threw off the parentheses and now I'm going to combine like terms. So I have 2 minus 4, -2. And then I have -3i's minus 2i's. -5i's. That's in the form of a plus bi, so I'm done. Do you have questions? If you do and you don't understand something, you need to ask, please. No questions whatsoever. Okay? We're going to do number 1 together. Here we go. So number 1 on the worksheet. It has -5i minus 8 plus 8 plus 3i. Now look at the problem, guys. Look at the problem. Is there any multiplication whatsoever here? No. Okay? So with this, we're just combining like terms. So I'm going to drop the parentheses off these things. -5i minus 8. And then we have plus 8 plus 3i. Now notice we don't have any negatives in front of any parentheses that we need to distribute through. So does everybody see how I just rewrote this without parentheses? Now we're going to combine the real parts and then we'll combine the imaginary parts. So we have 8, -8 plus 8, which is -8 plus 8. Guys, don't think so hard about it. What's -8 plus 8? 0. What?
The worksheet. That's negative.
Oh. Oh, yay. So I have the wrong problem. Okay. So this was negative. Did I mess up on anything? Nope. Okay. All right. So this is negative 8. I dropped off the parentheses. Okay. So then you're right. Negative 8 plus negative 8 is negative 16. Just combine those. Now we'll combine our imaginary parts. Negative 5i plus 3i minus 2i. It's in the form of a plus bi. Yes. Yes, I see what you were going to ask. All right, careful. Look at this one. Do not start doing the worksheet. You're going to get it wrong. So you might want to watch. Here we go. Looking at this one. Simplify the complex number. 2 minus 3i minus 3 plus 4i. Now, once again, guys, we have subtraction here. So guess what you need to do? Anytime you have subtraction, it's in front of parentheses. Did you hear me? In front of parentheses. This is what I would do. Write a negative 1 there. There's always a 1. It's negative 1. Now, this is going to prevent those of you that can't quite get these signs right in the future to do these correctly. So now we have negative 1 times all that stuff. Does that make sense? Now let's distribute that through. Negative 1 times 3. Negative 3. Negative 1 times positive 4i's. Negative 4i's. Now we've taken care of the sign issue. We don't distribute any more negatives. We're done. If we do it this way, it's nice. Now we can just drop these down. There wasn't a negative in front, so I'm just going to drop them down. So we have 2 minus 3i's. Questions on how I did that? Do you see how if you times that negative 1 through, it's going to help you not make those little errors? Okay, awesome. Let's combine our real parts. Let's combine our imaginary parts. 2 minus 3. Negative 1. And then negative 3i's minus 4i's. Negative 7i's. And that's in the form of a plus bi. So we're done. All right. Okay, I'm going to do problem number, oh, wait, let's see here. Well, I won't do another one. We'll do this one, and then I'll let you work for a while. So we have negative 2 minus, because this one's tricky, negative 2 minus negative 3 plus 2i minus 10. Is there a negative in front of parentheses somewhere? Right there, so I'm going to write a negative 1 and distribute it through so I don't make any sign errors. Negative 1 times negative 3, positive 3, negative 1 times 2i, negative 1 times 2i, negative 2i's. Now we distributed all the negatives that we needed to, right? So now we'll drop down everything else. We had negative 2, this was positive 3, so it'll be plus 3. And then we have this negative 10. Questions? Let's combine the real parts. Negative 2 plus 3 is? 1. So we have 1 minus 10. Negative 9. And then we have negative 2i's, no other i's to combine it with, so negative 2i's. That's in the form of a plus bi. Are you ready to practice on your own? Do problems 2 through 5. Okay, so now we're going to be multiplying complex numbers. This is where it gets a little bit more tricky. Adding and subtracting, you're simply combining like terms in a sense. Combining the real parts, combining the imaginary parts. Now, same idea somewhat with multiplying, but it's going to take some more thought, okay? So just recall this. We know that the square root of negative 1 is I, right? So if that's true, then if we square this side and square this side, then our root cancels out our power. True? So we have negative 1 is equal to I squared. So that's something you have to have memorized. I squared is equal to negative 1. That is a true statement. I squared is equal to the value of negative 1. Something you have to know. So everybody got that down so that we can start multiplying. All right, let's multiply. Okay, so now just before we get started, guys, pay attention. On the test, you're going to see addition of complex numbers and multiplication of complex numbers. Two totally different things. Do you see how you can get them confused easily, though? They kind of look the same. They have parentheses. The only difference is the plus sign versus the nothing there. This is plus, just combine like terms. I always see it, never fails on a test. Our students given this problem, and they double distribute, and they multiply. Just combine like terms if it's addition, and then here, yeah, you'll have to double distribute. Please don't make the error, okay? All right, let's go ahead and start doing this. Here's our first example. So we're going to simplify 2 plus 3i times 4 minus 2i. Now, once again, the reason we know it's times is because there's nothing in between there. So we have to double distribute. Did you hear me? You have to double distribute. So what we're going to do, guys, we have to take this side and multiply it to this whole side. So use the little trick I showed you, drawing your arrows. Go through it slowly. So I'm going to focus on 2, and I'm going to distribute it through to each term over on the other side. 2 times 4 is 8. Then I'm going to distribute 2 to the other term. 2 times negative 2i's. Negative 4i's. I'm going to pause. Is there questions? Now I've got to distribute the second term through to each term over here. So positive 3i's times 4. Positive 12i's. And then positive 3i times negative 2i's. Careful. Negative 6i squared. I'm so glad you didn't forget this squared part. Questions on why we got I squared? Okay, let's combine like terms here. So we have 8, negative 4i plus 12i's. How many i's? Positive 8i's. Very good. So we just combined negative 4i plus 12, and we got positive 8i's. And then we have minus 6i squared. Now, if this was quadratic, if we were dealing with quadratics, not i's, we would stop here. We would write it in standard form and then stop. Well, depending on what we were asked to do. If we were asked to solve, we use the quadratic formula. This, though, we're dealing with imaginary numbers. Well, we know, little aside, we know I squared is equal to the value of 1. Right? So we have right here, guys, pay attention to the details. This is negative 6 times by I squared, yes? So what we truly have then is negative 6 times negative 1. So what we're going to have is 8 plus 8i, and then we're going to have negative 6 times negative 1, which is positive 6. Now do we have another? Good. Yep, now we have 2 whole numbers, so we can combine those. So we'll be doing 8 plus 6, which is 14. So we have 14 and then plus 8. So with complex numbers, if you ever get to your final answer and have an I squared, you're not finished. You've got to change it to negative 1. Any questions on that? Okay, we're going to do problem number 6 together. So if you want to do it on your worksheet, that's fine. We're going to go through it together. So we have this. Negative 4 plus 5i times negative 2 minus 7i. Now once again, I'm going to start with negative 4 and distribute it through to each term over here carefully with my sign. Negative 4 times negative 2. Guys, negative 4 times negative 2. 8. Negative 4 times negative 7i's. Positive 28i's. Good. Now I'm not done. I've got to distribute the second term through to each thing. 5i's times negative 2. Negative 10i's. And then positive 5 times negative 7i's. Negative 35i squared. Now, I'm going to, before I combine like terms, I'm going to change my I squared to be what? Negative 1. So what we really have right here is negative 35 times negative 1, which is positive 35. Does everybody see what I just did? So I don't have that anymore. So then combining my terms, 8 plus 35. 43, 8 plus 35. And then we have 28 minus 10 i's, which is positive 18 i's. It's in the form of A plus BI, so we're done. Okay. Do you feel comfortable with multiplication? Do problems? Oh, wait. I won't go through this one. I'll just tell you how to rewrite it. 2 minus 2 i's. Do not just think you can square this and square this. That's called breaking the forbidden rule. You can't do that. You have to rewrite this one as 2 minus 2i times 2 minus 2i. You guys will understand that and know that? And then you double distribute. Okay, awesome. Then I won't waste your time. 7 through 10, go. We'll go through this next one. So now we just learned how to add, subtract, and multiply complex numbers. Now we're going to be dividing complex numbers. So once again, I need you to come back to me or you're not going to know how to do these. So I have you taking notes again. Here we go. So first of all, here's the problem, guys. Just like we can't have a rational in the bottom of a fraction, you know, when we were rationalizing denominators because there was a square root or a cube root or some sort of root in the denominator of a fraction, that it goes to be true also for our complex numbers. There cannot be an I in the bottom. Top is totally fine. If it's in the denominator of the fraction, meaning bottom, you've got to fix it. So we're not rationalizing, but in a sense, it's the same idea. We are, in a sense, rationalizing the denominator here. Okay, so does everybody see the problem? It's not the 2, it's the I. Does everybody see that we have an I in the denominator of a fraction? So think about it. We know that I squared is equal to negative 1. Is negative 1 a I? No, it's a negative 1, right? So if we, since this has an I, if we multiply the bottom to I, we've got to do it to the top. Now, once again, the reason we can do this is because we're really just multiplying by a fancy 1. I over I is 1. Okay? So if we do it to the bottom, we have to do it to the top. So now on top, also keep in mind that I is being multiplied to the entire top. So you need to put it in parentheses. Questions on what I'm doing here? Let's distribute I through. I times negative 2 is negative 2i, right? I times negative 3i is negative 3i squared. Very good. And then that's over 2 times 2i times I, which is 2i squared. Now I'm going to fix all my I squareds to be negative 1. So what we really have is negative 2i minus 3 times what? Negative 1. Does everybody see how this is negative 3 times I squared? Same thing as negative 3 times negative 1. And that's all over 2 times I squared, so that's 2 times negative 1. Questions on what I did? Now let's simplify it further. I wish I could stand over here and write, but it's really hard. Okay, so looking at this negative 2i, we still have that. So we have negative 2i, and then we have negative 3 times negative 1. Plus 3, and that's all over what's 2 times negative 1. Negative 2. Now also, this answer I probably accept, but at the same time, this negative underneath they'd also probably distribute that through, because that's just like dividing by negative 1. So I'm going to distribute the negative through to keep going with this. So we have negative 2, negative divided by negative is, and we can't divide the 2 out, guys. We have to be able to divide by all 3 things here. So we can't divide the 2's out. Does everybody hear me? Okay. So looking at this, though, we should distribute the negative through. What's negative divided by a negative? Positive. So we have 2, and then, so we have 2 i's, and then we have 3 divided by negative 2. That's going to be negative, right? So negative 3 divided by, and now it's just a 2. So really what I just did was I pulled out the negative from here and said multiply all this by negative 1, and that would have made this positive, this negative. And then now it's just a 2 on bottom. Does that make sense? This is how, like, on an ACT you'd see it written, so that's why I want you guys to practice. And on an end of level, they would finish out those negatives. Does that make sense? Okay. All right, so do we need to go through another one, or do you feel like you're pretty confident with those? Okay, you feel confident. Thumbs up if you're confident. If you need another one, thumbs up. Okay, awesome. So those of you that are ready, move on. If you don't want to watch this one, that's fine. I'm going to go through this one for those that want to watch it. So you can do problems 11 and 12 now. If you want to watch, I'm going to go through this one. You can ignore me if you don't want to watch. That's fine. So we have 2 minus I over negative 3I. Once again, the problem is the I in the denominator of the fraction. So I know that if I have an I squared, it will go away. So I'm going to multiply the bottom by I and the top by I. Then I throw in my parentheses and I'll distribute I through. So 2 times I. And then we have negative I times I, which is negative I squared. So then on bottom, I have negative 3 times I, which is negative 3I squared. Then I'll go through and change all my negatives to be, all my I squareds to be negative 1. So what we have here is instead of I squared, we have a negative 1. Instead of an I squared, we have a negative 1. So we have 2I, and then we have minus negative 1. So that'll be plus 1. And then on bottom, we have negative 3 times negative 1, which is positive 3. Now, if all 3 things could divide by the same thing, you would divide it. But this can't, so this one's done. Okay. Now you can do problems 11 and 12. So now we're shifting gears a little bit. That was a good introduction into this next part here, kind of. Okay, so we're going to be now talking about the conjugate root theorem. So this is totally shifting gears, but we needed to get back into imaginary numbers to be able to understand what happens with the conjugate root theorem and be able to do it, okay? So conjugates. First of all, before we even get into the conjugate root theorem, we need to know what a conjugate is. So conjugates have the exact same terms, just to change your sign in between. So once again, conjugate just means they have the same exact terms, just to change your sign in between. So notice, if we have term A plus B, the conjugate of that would still be A and still be B. It's just the sign in between would be the opposite. Does everybody understand what a conjugate is? Exact same terms on the front and back. The only difference is a change of sign in between. Does that make sense, everybody? Okay, so now here's the rule. So interesting rule. We've been finding zeros, we've been finding roots, right? Okay, so when you do find a root, an interesting fact for you, if you have a rational root, meaning irrational, if you have an irrational root, which irrational means can't be written as a fraction, can't be written as a fraction. If you have an irrational root, then its conjugate must also be a root. Conjugates come in pairs. So if you have an irrational root, there is another root for sure. It's the conjugate of that root. Only though if it's irrational, meaning can't be written as a fraction. Also with the conjugate root theorem, if you have a complex root, so if you get a complex number as a root, its conjugate must also be a root. So once again, if you have a complex root, then its conjugate must also be a root. Now think about it, this is kind of cool. The quadratic formula already accounts for both the plus and minus roots, right? So with the quadratic formula, it already accounts for the 2 complex roots, if you have complex roots. Now that's only if you have a negative under the square root. Anyways, just an interesting fact. So if you have a complex root, then its conjugate must also be a root. So really this will make more sense when we practice it. But guys, this rule only works for complex roots and irrational roots. If it's a number that's not irrational, meaning if you have a number that can be written as a fraction, its conjugate is not a root. This only works for irrational roots and complex roots. Is everybody okay with that? Okay, let's practice. What's the other root of 2 plus 3i is a root? What's the other root? There's one other. 2 minus 3i. Okay, so the answer is 2 minus 3i is the other root. Very good. Very good. Any questions on that? So we would have two roots. X is equal to 2 plus 3i, and x is equal to 2 minus 3i. We have two complex roots. They're conjugate roots. Good. Next one. What is the other root if the square root of 5 minus 3 is a root? Now, everybody listen. Type this, practice this. This is an irrational number, meaning it can't be written as a fraction. Try typing it into your calculator. Type in the square root of 5 minus 3, hit enter for me. The square root of 5 minus 3, hit enter. Now change it back to a fraction. Hit math, enter, enter. We'll put it back in a fraction. No, it just keeps putting it in a decimal. That means it can't be written as a fraction. Thus, its conjugate root must also be a root. So looking at this one, if the square root of 5 minus 3 is a root, then also what must be a root? Square root of 5 plus 3 is also a root. We have two roots. X is equal to the square root of 5 minus 3, and x is equal to the square root of 5 plus 3. Very good. Very, very good. Questions on that? Okay. Another one. What's the other root if 7's a root? Negative 7? Anyone beg to differ? Nope. Nope. Is 7 an irrational number? Is it a complex number? No. So, is it conjugate a root? No. Do you understand the rule now? Numbers are not irrational. Like a whole number. If it can be written as a fraction, you can't say its conjugate's also a root. The rule says if you have an irrational root or a complex root, then its conjugate's also a root. Does that work for whole numbers? Does it work for fractions? No, fractions can be written as a fraction, right? Does everybody understand that it doesn't work for numbers or fractions? Those are just roots. So once again, I'm going to ask you one more time. What's the other root if 7 is a root? We don't know, right? No. Does that make sense? X is equal to 7 is the only root we know. Do not make the mistake of saying x minus 7 is also a root. Not true, necessarily. All right, what's the other root if x is equal to 2 is a root? What's the other root? Okay, I'll rewrite it for you. This is the same thing as 0 plus the square root of 2, right? So what's the conjugate root?
0 minus square root.
Square root 0 minus the square root of 2. So we have x is equal to the square root of 2, and x is equal to negative square root of 2. Does everybody get that? Okay. So the square root of 2 is an irrational root. So is negative square roots of 2. Okay. What's the other root if negative 2i is a root? So if x is equal to negative 2i, what's the other root? X is equal to positive 2i. Very good. Does everybody feel pretty comfortable with that? Okay. Okay, so now we're going to go a little bit further. I'm only going to have you do one like this. Stay with me. Last one. This one's tricky. Please stay with me really quick. So it says, find any additional roots and then find the polynomial that has the given roots. Okay, so once again, find any additional roots and then find the polynomial that has the given roots. So if x minus 2i is a root, so if x is equal to 3 minus 2i, what's also a root? X is equal to what? 3 plus 2i. Very good, because that is a complex root. Does the conjugate root theorem apply with 2? No, that's a number. So we also have x is equal to 2. So I'm going to ask you, what's the degree of my polynomial if these are the roots? Degree 3. Isn't there 3 of them? Okay, so we need to keep going with this because this one asks us, find the additional roots, we did that part, and find the polynomial that has the given roots. So we know how to work backwards, right? Given this, we can work backwards and find the polynomial. So what we're going to do is we need to get this side equal to 0. So I'm going to subtract 3 from both sides. So we have x minus 3, and I'm going to also add 2i to both sides. So plus 2i which is equal to 0. Does everybody see how that adds up to be 0? Are we all okay? Okay. Now over here, we're going to get a set equal to 0. This is positive 3. We need to get it over to this side. What should I do? Minus 3 from both sides. So we have x minus 3. And we also need to subtract 2i from both sides. So now we have, look, that adds up to be 0. And then we have x. We need to get it to be equal to 0. What should I do right here? Subtract 2 from both sides. So we have x minus 2 is equal to 0. Now we know what we can do is we can bring them together since they're all equal to 0 and multiply it. So we'll have x minus 3 plus 2i times x minus 3 minus 2i. This times this times this. Now we need to go through and distribute all this. Now take my suggestion. This is a difficult problem. Okay? Look at it. You can already tell it's going to be difficult. If you take my suggestion, you're going to do better. These two were conjugate roots, right? Multiply those two together first. A lot of stuff's going to cancel out because they were conjugates. So I would always suggest multiplying those two together first. You need to, or you're going to make errors. So let's finish this one off. I'm only going to make you go as far on this as on one of them on the assignment. I'm only going to make you go as far on like one of them or two of them. I'll think about it, depending on how we participate. All right, so let's go through this one. Let's double this. Let's just triple distribute. X times x is x squared. X times negative 3. Minus 3x. X times negative 2i. Negative 2ix. Very good. Did you all see what I just did? Distributed x through. I'm going to distribute negative 3 through. Negative 3 times x. Negative 3x. Negative 3 times negative 3. Positive 9. Negative 3 times negative 2i's. Net positive 6i. Guys, so negative 3 times negative 2i's is positive 6i's, right? Okay. Are we all following? Okay. Now I'm going to distribute 2i through. So 2i times x is positive 2ix, right? Are you guys still following me? Positive 2i times negative 3. Negative 6i's. Positive 2i's times negative 2i's. Negative 4i squared. Then we'll combine like terms. Now look, so much stuff cancels out. Okay, so not to fret, a lot cancels out. We have an x squared, any other x squareds? We have x squared. Look, negative 3x minus 3x doesn't cancel out. That becomes negative 6x, right? Now look at this part. Negative 2ix's plus 2ix's is 0. So it's gone. And then we have plus 9. We still have that. Nothing to add to that. Then we have 6i's minus 6i's. Gone. And then we have minus 4 times I squared. I squared is equal to negative 1, right? So what we have is x squared minus 6x plus 9. And then what's negative 4 times negative 1? Plus 4. So combine like terms. X squared minus 6x. 9 plus 4 is. So this is what that multiplied to be. All that stuff, and it came out to be not so bad. Does that make sense, everybody? That was a lot of work. Okay, I'm laughing because you're right. I can't look you in the eye and say that wasn't hard, because it was. Okay, now we have to multiply x minus 2 in. Now we have to multiply x minus 2 in. Does everybody remember where the x minus 2 came from? Okay, so now we're going to multiply that in. So we'll distribute x through. X times x squared is x cubed. X times negative 6 is negative 6 squared. X times 13. 13x. Then we'll distribute negative 2 times x squared, which is negative 2x squared. Negative 2 times negative 6x is positive 12x's. Negative 2 times 13 is negative 26. Combine like terms, we'll have x cubed minus 8x squared, and then 13 plus 12 is 25x's minus 26. A lot of work. Cole's face, I just can't get over it. Okay. Yeah, Cole was willing to drop the jaw for all of you because, yeah, that problem was, yeah. All right, so you guys, that was hard, right? Be careful. Here you go, do these problems. Okay, so listen, I'm not going to make you do them all. Listen, and then I won't, okay? Do all on problems 13 and 15. So you know how I just went through that long process? You only have to do that on 13 and 15. Write that down. Now just find the additional roots on number 14, 15, and 16. That should take you 5 seconds, right? And then after that, you only have one problem at the bottom, which will finish off the worksheet. The only ones you have to do that long process for is number 13 and 15. Okay? All right. You guys are awesome. I love you all. It is. Okay. So what I was going to have you do for your ball activity was just look on your phones. Look on your phones to see what makes something considered a polygon. So polygons are a couple things. They're flat surfaces. So they're flat surfaces. They're also 2D shapes. So not three-dimensional. We don't get into three-dimensional until really we start doing three-dimensional math and calculus. Also, what makes something a polygon is that it's closed all the way, so that it's not open. There's closed edges. There's at least 3 sides. At least 3 sides. So circle is not considered a polygon. And you can't really make any shape out of 2 lines without connecting them and making another line that would actually make a polygon. Well, I guess you could, but it would not be considered a polygon. So if you did something like that, not a polygon. All right. That's all I was going to have you do, just to get some technology moving in the classroom. Does everybody kind of understand what a polygon is? Okay, awesome. So today we're going to be dealing with similar polygons. Now note, yesterday we were dealing with congruent triangles. We were using triangle congruence theorems. So we were proving that triangles were congruent, proving that they were equal. Now today we're going to be dealing with similar polygons, not just triangles, but we will see a lot of similar triangles today. There is a difference between congruent and similar, okay? So similar polygons, by definition, similar polygons. This is where I'd be taking notes. So this is 2-3. Now notice at the top of your thing it says 6-1. That's because that's where we were last year when we got to this. I didn't have time. My copies that I had sent would have been right. So cross that out and write 2-3 on the top. So similar polygons by definition have the exact same shape, but they might be different sizes. So I'm going to say that again. Similar polygons have exact same shape, but they might be different sizes. They might be the same size, they might be different sizes. But they will nevertheless have the exact same shape. Now these are the 3 properties that make something officially qualified to be considered similar polygons. So first thing's the easiest. It has to have the same number of sides. This one's pretty straightforward, guys. A square is not going to be a similar polygon to a triangle. They have different number of sides. So the first one's kind of, it goes without being said. The second thing, the second property is corresponding angles are congruent. We know congruent means equal, right? So once again, corresponding angles are congruent. So the angles will be equal no matter what. So even if we have this huge polygon and a small polygon, the angles will be identical. Exactly the same. So I have my picture of my identical twins. By definition, their DNA, identical twins, DNA is equal, it's the same. So, anyways, just keep in mind angles are exactly equal just like identical twins. All right, and then number 3, corresponding sides are proportional. Now notice I said proportional, not equal. So corresponding sides are proportional. They're not going to be equal. One of them is going to be really large and one of them is probably going to be small. So they're not going to be equal, but we will set up a ratio of corresponding sides and those must be proportional. They'll be equal. So that's the most important part. Now this is the hardest one for students to get, is that corresponding sides are proportional. What we're going to do though, is we're going to set up corresponding sides as a ratio. So this is, for example, look over here at these two triangles. What we're going to do is look at corresponding sides and set them up as a ratio. So look at this bigger triangle and this small triangle. Well, does everybody see how A and D fall in the same spot, but on different triangles? Okay, so we'll set up the ratio of corresponding sides. So A over D will be equal to, now that was this side and this side, will be equal to, now I started with the big, I've got to stay consistent, will be equal to B over F. Do you see how they sit in the same spot? Will be equal to B over F, which will be equal to the ratio of the other corresponding sides, so it'll be C over E. Do you see how C and E sit in the same spot, but on different triangles? Okay, C over E. So these ratios better be equal straight across the board. Now, keep in mind, you have to stay consistent. So, notice I went from big to small. I set up my ratios from big to small. You could have done from small to big, as long as you stay consistent. So I have A over D, that was the big on top. I have B over F, that was the big one on top. And then I have C over E, that was the big one on top. I stayed consistent. You'll get the same answer as me if you do it the other way when we're solving, but you've got to stay consistent. Does that make sense? All right. Now here are some symbols you're going to see. Similar is a little squiggly. Similar, we just learned the three things that make something qualify to be similar. And then congruent, we've seen that before. We were dealing with congruence yesterday. So it's the equal sign with the squiggly. That's what congruent means. Congruent means equal, similar means similar. Now when I say the word corresponding, it just means it sits in the same exact spot, but on different polygons. So corresponding means sits in the same spot on different polygons. Does everybody feel okay with vocabulary before we begin the actual problems? Okay. Another couple seconds to get that down, and then we'll just start practicing these, because that's how we do it. That's how we learn to practice. Okay, so here's our first problem. We're going to kind of go slow through this one. Make sure we're good. So it says, given the two polygons are similar, so we're told they're similar, find all the missing sides and all the missing angles. Now notice, right here, very important, I'm going to highlight it real quick. Notice right here, I have a congruence, a similarity, sorry, not congruence, it's a similarity statement. And I'm going to use that. I'm going to use that very much so. So looking at this, we have this small triangle and this large triangle. You're going to use a similarity statement to decide which angles are equal to which angles. So notice, your similarity statement will hold true across the board. So A is to D. You see how they sit in the same spot? So A and D are corresponding angles. B and E are in the middle, so they are corresponding angles. And then also C and F are corresponding angles. So what I'm going to do is have you look right here for a second. Notice we have all of this triangle. We're trying to fill in all the missing stuff. We're missing the green angle. We're missing the red angle. But if you think back to similar polygons, we know what about the angles. No matter the size, the angles are, well, of a triangle, they have to be 180. But I'm saying of a polygon, what do we know about similar polygons? The angles will be the same, equal, no matter the size. So let's look at this. Could we find angle B? Yes. Angle B, we could, because look over here we have angle B given, angle E, which goes with angle B. So once again, everybody look. Does everybody see how B goes with E? So B goes with E. So if E is 68 degrees, what's B? 68 degrees. Very good. Questions on that? Okay, let's do the other one. We know angle C is to angle F. So if F is 77 degrees, what's angle C? 77 degrees. And last, we're looking now, let's now take my suggestion. When doing these, the first thing I do is fill in all the angles, and then I'll go through and fill in the missing sides. If you take my suggestion, you won't miss things. Okay, awesome. Yes, tell us.
What?
How do you find angle D?
14. Oh, the angle D now.
How do you find angle D?
It's 35.
How do you know it's 35? Good. D and A are corresponding angles, thus they are equal. So 35, if A is 35, B is also 35. Does everybody see how I filled in all my angles? Any questions? That part's the easiest part. So now let's go through, we're trying to fill in the entire triangle. So we have to fill in any missing sides. Well, look at this small triangle here. We have all the sides, right? Okay, so we're good there. But look, at this we have 12, 20, and we don't know this. So I'm going to call it X. We don't know it, so I'm going to call it X. Now we know, though, if we have similar polygons, we can set up a ratio of corresponding sides and solve for X. So let's look at some corresponding sides and set up a ratio. So first of all, we know that DF, if you look at that, that would be DF is to AC. Does everybody see how DF falls in the same place as AC? So DF is the same as AC. So those are corresponding sides. So I'm going to set up a ratio. Now, if you want to go from big to small, that's fine. Or from small to big, that's fine. You just got to stay consistent. I'm going to go with small to big. So 7 over X, I'm setting up the ratio of the corresponding sides, is equal to, and now I'm going to use a different ratio. Now, we know this side is 10, but what side corresponds with AB? DE. So we're going to have 10. We're going from small to big, so we're going to have 10 over, so AB is to DE. So find DE. So these two sides are corresponding. I chose to go from small to big, so I've got to say from small to big. Now I could have used, instead of 10 and 20, I could have used 6 and 12. I just randomly chose 10 and 20. Those are corresponding sides. Does that make sense? And now I can solve for X. Yeah. Okay, let's do the math. You're right. Let's do the math, though. So with this, I have a fraction on the left, a fraction on the right. Do we love fractions? Not necessarily, right? So I'm going to cross multiply. So I'm going to multiply both sides by 20, but it divides out over here, right? Cross multiplication, guys. I'm going to multiply both sides by X. What happens to the X over here? Divides out. So somebody tell me now. We have 20 times 7, which is 140. So I just did 20 times 7, which is 140, which is equal to 10 times X, right? Now you have to know how to do this math because we're going to be dealing with fractions. You're not going to always be able to tell. Does that make sense? So are you watching? Okay. How do I solve for X at this point? Divide both sides by 10. So we get 140 divided by 10 is, so 14 is equal to X. So we know that that side is 14. Now look, check all your angles. They're all filled in. Check all the sides. All filled in. Any questions on that one? We're going to do one more, and then I'll let you practice. Here we go. One more. So it says, given the two polygons are similar, find all the missing sides and angles. Now look, you can't just go off of your, looking at it. You've got to actually look at the similarity statement. Because these are twisted and turned, and you can't always just tell from looking correctly, anyways. So looking at this, we know that triangle ABC is similar to triangle EFG. So let's go through. The first thing I do is fill in all my angles. So I'm going to fill in angle A. Well, what is angle A equal to? Angle E. What's angle E?
88.
So this must be 88 degrees. Questions? Okay, let's do another one. Angle C is missing. We need to find it. Well, angle C goes with what angle? D. So what's angle C? 60 degrees. Now, once again, we have all our angles on this one. We need an angle on this. Okay, so we're missing angle F. What is F the same as? B. 32. Very good. Questions on that? I filled in my angles. Now we have to fill in all the missing sides. Pay attention carefully. This side is 2, this side's 12, this side's 11. We don't have to find any missing sides on this big one. But looking at this, notice I'm missing this side, right? And I'm also missing this side. I'm going to call them different things so that I don't get them confused. Does that make sense? We've got to find 2 of them. Now what we can do is set up the ratio of corresponding sides to solve. So first of all, I'm going to use for sure the one I know. I'm going to use for sure the one I know. So I'm going to do 4 over, what corresponds to DF? So look on here, DF, what corresponds? CB. So CB. So 12 and 4 are corresponding. So I'm going to do 4 over 12 is equal to, now I chose to go with small to big again, but if you go from big to small, as long as you stay consistent. Now let's find x first. Let's find x first. So psi x is FE, right? So what goes with FE? BA. So we're finding x. So what goes with BA? 2. So we're going from small to big, because that's what we did first. So we'll do x over 2. And then we'll cross multiply and solve. Now in this one, if I cross multiply both sides by 2, it's going to divide out over here, right? Do I need to do anything with x? Is x all alone now? Yes. Okay. So now you'll do it on your calculator. 2 times 4 is 8 divided by 12, which is equal to x. What's the decimal? 4.5. 1. You're right. It would be 1. True. So we know that x is 1.5. Now let's find question mark. We can use this same ratio. So I'm going to use 4 over 12. So 4 over 12 is equal to, this time we're doing question mark. We're going from small to big. Is equal to question mark over what? What goes with DE? 11. So question mark over 11. Are you following me? Okay. So then we'll cross multiply. So I'm going to get question mark alone. I multiply both sides by 11. Now I happen to not have to cross multiply by 12 again because question mark's alone. So 11 times 4 is, we have 44 over 12, which is equal to question mark, and then question mark is equal to what? Yeah, we should probably round to the nearest 10. Okay. 3.7. Very good. So this is 3.7. I found all the sides and all the angles. To find the sides, you'll set up the ratio of corresponding sides, then cross multiply and solve. Do you feel comfortable? Okay, last one, then I'm going to let you work. So complete the congruent statement. So we know that JKLF is similar to DCBA. I wouldn't use the pictures. You don't know how the picture's been turned or what it's doing. I would use my similarity statement because the similarity statement doesn't lie. So angle J is equal to which angle? D. Angle D. Make sure you type angle D. Now I'm going to use that rather than look at the picture. It's just as fast or easy and it's more accurate. So then angle B, so angle B is to L, so angle L. Questions? Okay. Now looking at this one, watch carefully. So we have KF over CA. So that's KF over CA, which makes sense. Does that make sense since they're corresponding? Is to LF over question mark. So I'm going to go to LF. What is the same as LF? BA. Very good. Last one here. So we have CD. So CB over JK, which makes sense. KJ, I meant to say, sorry. KJ is equal to question mark over LJ. So I find LJ. What goes with L and J? BD. Very good. Now that's a lot easier than looking at the picture. You're a lot more accurate because some pictures are tricky. Use the similarity statement and you'll never be wrong. Does that make sense? Do you get it? Do problems 1, 2, 3, and 4.